That was all of this that we did just yesterday on Monday. On Friday, that was problems 1 and 2 where you had to graph it and find the zeros. Solution, that was like 3 and 4. And we'll use the quadratic formula. Now, a special. Today we're going to put all the techniques that we've used together. Okay, we've talked about and practiced putting the polynomial in standard form, getting it equal to 0. Yesterday, if you recall, we did the rational root theorem. I'm going to jump to that slide so you can see it. Then we're going to graph it. We did that. Then we're going to use synthetic division to test to see if we have an actual. Then lastly, we're going to solve that new equation. I'll explain what depressed means in a. I've kind of generalized this last thing to use quadratic methods. Remember, sometimes we can use the square root method. Sometimes we could factor. And then we can always use the quadratic formula. So let's look at an example. Let's put all of these techniques. Let's put all of these techniques together. We know how to get it equal to 0. That's pretty easy. Just write it equal to 0. Sometimes we have to slide stuff over by subtraction just to make sure it equals 0. Rational root theorem. Remember, that's the P over Q stuff. Okay. Graph it with Desmos. Okay. Look for those answers. Okay. You want to look for whole numbers, or rather integers, I should say. And finite decimals that come to an end. And remember, that's kind of hard to tell sometimes because the technology doesn't tell us. Okay, you have to look, and then you have to test it to see if you were right or not. Then you use synthetic division to test those. So test answers from step 3. You've looked at your graph, you think these are your answers, you test them by using division. Sometimes it's a single division. So if it's like an x cubed, you only have to divide it one time, because then it'll give you an x squared, and we know how to solve x squareds. If it's an x to the 4th, the first time you do your division, it'll become x cubed, but then you got to do another division to get it down to an x squared. So it'll take 2 divisions. If it was a 5th power, you'd have to do 3 divisions. And then lastly, once you get it down to a quadratic, then you can either use the square root method, you can use quad formula, or you can try to factor it completely. So we got 3 different ways we can try to attack that quadratic. Oops. All right, now this first statement here, let's put it in standard form, and you got to be you just have to understand what we're talking about here. When we say find the solutions to a polynomial like this, you can't really find the solutions to this because this has infinite number of solutions. I plug in an x, out comes a y. But what we're looking for are called these zeros when we say solutions. And that means take the polynomial and set it equal to 0. So we're actually solving this equation when we say solve it. Now there's only a few particular solutions that make that one true. In fact, there's 3 of them. So that's step 1. Okay, now we're going to use the rational root theorem, and we're going to try to find, or at least list, some of the solutions. So we make our list of p's. Remember, p's come from the constant term. All of its factors. And q comes from the lead coefficient. And then p over q. Now in this case, because q is only 1, it's just going to be really our p list, because everybody over 1 is just themselves. 4 divided by 4 is 4, and 8 divided by, or 4 divided by 1 is 4, and 8 divided by 1 is 8. So there's the possible rational solutions. Next step, so that's number 2. Next step, we're going to graph this thing. So we pull out Desmos and we graph it. And I've got the graph down here. So let's take a look at this guy. And in this graph, what we want to look for, any zeros that we can find. And clearly we have a 0 right here at 1. Okay? And that's no decimals with that 1. It's just a pure 1. Which means, that's going to be one of our solutions. But there's a way to check that thing to see if it truly is a 0. And that was this step 4, which we did yesterday, which is how do you check to see if something is a solution or not? And the answer is you use synthetic division. So we think x equals 1 is a solution. Now this implies that x minus 1 is a factor. So if 1's a solution, x minus 1 is a factor, and therefore we can do division. And we go x minus 1 and we divide it into the polynomial. Now, you don't really have to write this statement, because if we were doing this division, we would actually just put a 1 in the box and we'd use synthetic. But it's important to remember you're dividing out a factor when you put a 1 in the box. You're dividing out x minus 1. And so we carry out our division. Now, remember, 1 we think is a solution because of the graph. And so we better get a 0 for a remainder. It better divide evenly into it. Otherwise, it's not a solution. So now that says yes, 1 is a solution. Why? Because the remainder equals 0. And so essentially now we have this polynomial factored. Okay? The first factor was the factor that gives us 1 as a solution. That's x minus 1. And then this x squared, no x's plus 8 is the other factor. Now, this factor right here, we can actually treat as a separate equation, because once it's factored like this, you set each factor equal to 0. That gave us the x is 1. And this one equals 0. We can solve that now. This is what I say, solve with these quadratic methods, because this is a quadratic equation. Now let's talk a little bit about vocab. This guy, this x squared, is called a depressed equation. And the reason it's called depressed is because the original equation, and I'm going way up here, was an x cubed equation. We divided out the x minus 1, and we have depressed it down to an x squared. So it went from an x cubed to an x squared, so it went down by 1 degree, and that's why we call it depressed. Now our final step, we just have to solve that little equation there. So I'm going to write it off to the side here. We just have to solve using some of our quadratic tools. X squared plus 8 equals 0. We got a couple of ways to do this. We could use the quadratic formula, but this one, man, it's set up for the square root method. Man, do I get a negative 8 here? Well, they're going to really work you on this problem. So I square root both sides. Now be careful here. We are square rooting a negative number. Remember back from last semester, if you square root a negative, you poke out the I. It's a complex number at that point, or an imaginary number. And now we have to simplify square root of 8. 8 is 4 times 2. The square root of 4 is 2. So we end up with plus or minus square root of 4 is 2. The I is outside, and then an 8. So we ended up with 3 total answers. X equals 1, found that from the graph, and plus 2i root, should be plus 2i root 2. Sorry about that. 2i root 2 and negative 2i root 2. And these are imaginary answers. They will never show up on the graph, and this is the only way we'd be able to find them. So that's our 3 answers. It is quite a process, everybody. Let's look at another one. So here we go. Let me get things zoomed in appropriately so we can see everything. First thing we're going to do, get it equal to 0. Second step, we're going to list all of our possible solutions using the rational root theorem, possible rational solutions. Factors of 6. And then our list of solutions, just making P over Q. We're going to have a lot here. We first do the green 1 over the red 1, which is just 1 over 1. Then 1 over 2, the green 1 over the 2. 1 over 3, and plus or minus 1 over 6. Then we have to do the 2's, so we do 2 over 1, which is 2. 2 over 2, which is also 1, so we don't put it. 2 over 3. And then finally 2 over 6, but 2 over 6 is 1/3, so we don't need to put that one. And then lastly 4 over 1, which is 4. 4 over 2, which is 2. We already have that in our list. 4 over 3. And then 4 over 6, which is 2/3 again. So there's our possible rational solutions. Then we go to the graph, and we just say, all right, which ones does our graph tell us we have? Well, it looks like we have a 0.5, a half. This one I don't know about, and that one, that's a little bit tough. It might be 2/3. 2/3, if you remember, is 0.6 repeating, so that might be negative 2/3, but we're going to have to check that. And I don't know what decimal that, or fraction that is, but I don't think it's any of ours, because that's 2 in some fraction, and we don't have anything that's 2 in some decimal part. So we're going to check 0.5 and 2/3. Now here comes a new, not a new step, but an efficient way to do this. So right now we think that x equals, based on that graph, 0.5 was an answer, and we think x equals negative 0.66, and we think that's a repeating 6 as an answer. Let's make these things fractions. That'd be a 2/3. So we can check either one first using synthetic division. I'm going to do the half first because I think that'll be easier. I'll write down my coefficients. And I say it's going to be easier because all I have to do is take halves of things when I multiply them. So I bring down the 6, and half of 6 is 3. Add them up. Half of negative 8, negative 4. Half of negative 20 is negative 10. And half of negative 8 is negative 4. And again, I better get 0. Otherwise, this half would not be a solution. At this point now, I do know for certain that a half is a 0 because it just made the remainder 0. It's a solution. I still haven't tested this one. Now, I have depressed the equation at this point. I started with x to the 4th way up here. I just did a division. Remember, we just divided out x minus a half, the factor. And so it reduces it. It depresses the equation. It's now an x cubed equation. It just goes down in descending order. And now I check negative 2/3, but when I check the negative 2/3, I don't go back to the original. I do it inside this, or with this depressed equation. And you'll see why in a second. So now I'm going to do synthetic with the 2/3. And I write down 6, -8, -20, -8. This will be a little bit tougher. Okay, 6. When I bring it down, then I come over here and I just do my little fraction math. 3 goes into 6 twice, so it's 2 times 2, and it's going to be negative. And I add. Then I run down and I do a little fraction math. 3 goes in 12 4 times. -2 times 4, -8. Ooh, that's a -4. That'll be a +8. That gives me -12. And I've already done -2/3 times -12. That's +8. And again, I better get a 0. Otherwise, it's not a solution. And now I've depressed the equation again. So the first division took it from an x to the 4th, depressed it to an x cubed. The second division took the x cubed, reduced it now to an x squared. 6x squared minus 12x minus 12 equals 0. And at that point, I can solve that equation because it is quadratic. So let's give ourselves a little more room here. Take this guy up over here. Now, it is just a quadratic equation. Let's look at ways we can solve it. The first thing is, notice everybody's divisible by 6. So you could factor that 6 out, but you can also, remember, always divide by the same thing on both sides. So I'm going to divide both sides by 6. And you'll see how simpler it becomes. Excuse my voice. See, we could try to factor that, but I don't think it's going to factor. We can't use the square root method because it does have a b term, the 2x in the middle. So we're going to have to go with a equals 1, b equals -2, c equals -2, and we're going to have to use the quadratic formula. And this again is something we just practiced the other day. So we're going to have negative of negative b, so that's going to be a +1, or a +2, -2. Then it's going to be -2, and we have to square it. All over 2 times a. So it's 4 plus 4 times 2. Now, note again, and we've talked about this, double negatives, that's going to be a positive. And it's just 4 times 2, so it's +8. We're almost there. Oops. Equals 2 plus or minus the square root of 12 over 2. 12 now, it factors as 4 times 3, and we can square root that 4. So 2 plus or minus square root of 4. And everybody's divisible by 2. 2 over 2 is 1, and 2 over 2 is 1. Simplifies to that. Now you have to make sure at the very end you collect all your solutions. First solution we found was way up here, that 2/3, or the 1/2 rather. Then we found the -2/3. Remember, the remainder came out to 0. Then we got these two radical answers, the 1 plus √3 and the 1 minus √3. But in general, you write your final answer like this. That would indicate to any mathematician, like you are, that we mean 1 plus √3 and 1 minus √3. We found 4 solutions. It was an x to the 4th equation way up here at the beginning. And we have now found all of those answers. Yes, these are complicated problems, so just hang in there. If you think about these steps, though, there's no step in here that you do not know how to do.